What's up, everyone? Welcome to AP Stats. In this video, we're going to be talking about collecting data strategies to collect data. So before you start collecting data, you have to first identify your population of interest. By far, one of the most important things. The population of interest is the group of people or objects, animals, places, whatever it is, you want to collect information from or about, right? You can't just blindly start collecting data from people that don't matter to you. You need to first identify who is the group of people, objects, places, whatever, the group of individuals that you care about, and that's where you need to go and collect your data. So we call that the population of interest. Now, what type of study is needed is what we need to answer, right? This is something that we have already previously discussed. We talked about observational studies, where researchers simply observe or ask questions to collect data, looking at a single variable or looking at an association between two variables, versus an experiment where it's used to determine if one variable has a direct impact on a second variable. Again, here we're looking for that cause and effect relationship between two variables. So you have to be able to say, what's my population of interest? Who do I want to go to get my data from? And then, how am I going to get that data? Am I going to do observational study where I'm just going to, kind of observe and ask questions? Or do I need to conduct an experiment? So let's start with collecting data for an observational study. So you've decided that you just are going to observe or ask questions. How are you going to collect that data? So again, your goal is to reach your population. If the population is small enough, you can ask every single person in the population your questions or observe them all. This is called a census, where you are literally obtaining data from everybody that you care about. Now, if your population is very small, like students who take AP statistics at Twinsburg High School, well, listen, I can talk to every single one of you and get all of my data. Or if maybe you own a small company that has 100 employees, you could certainly do a census and ask all of them if that is your population of interest. But sometimes populations are way too big, like if your population of interest is all cardinals, all birds, all cardinal birds, right? Well, there are millions of cardinals across this world. You cannot possibly get to all of them, so that is where we select a sample. A sample is a subset of a population that needs to represent that population, otherwise it's biased. So it's super important that your sample is not just any old sample. It's a sample that truly represents the population. Just as a rough example of what I'm talking about here, if your population is all cardinals, well, guess what? There's male and there's female cardinals. But if your sample only contains male cardinals, well, then it's considered bias. It's overrepresenting the males, and that could be an issue for the data you're collecting. So you want your sample to be a nice mix of males and females. That way it represents the population, which has males and females. Obviously, we'll talk a little bit more about that idea as we go throughout this, but it's important to say right now that your sample needs to represent your population. Otherwise, it could lead it to being biased, which means, well, not good. So we also want to talk about this real quick. This is kind of like an idea that's going to matter like long term as we go throughout all the units, but it's an important idea to bring up right now, and that is the difference between parameters and statistics. So a parameter is values that summarize data for an entire population. So if you have a number that represents an entire population, it's called a parameter. For example, if I was somehow, some way, I don't know how, able to get the weight of every single cardinal in the entire world, then I could get the average weight of all cardinals. If that average represented all cardinals, then it would be a parameter because it came from the population. Or if I found out that, if I was somehow able to get to every cardinal in the entire world, and I found out that 18% of them are infected with a particular disease, that would be a parameter because it's a proportion, 18% that are infected with the disease that came from all cardinals, the entire population, that would be a parameter. Whereas a statistic is the values that summarize data from a sample. So if your value is only coming from a sample, it's known as a statistic, okay? Which is, of course, a sample is, of course, a subset of a population. So if you get a sample of, let's say, let's just say you get a sample of 150 cardinals, lowercase n is typically the symbol we use for the sample size. So if we have a sample of 150 cardinals, and of those 150 cardinals, the average weight is I'm literally making this number up, 130.9 grams. Okay, well that would be considered a statistic because it only came from a sample of cardinals. So if the average came from all cardinals, it's a parameter. If the average came from a sample, it's a statistic. Another example would be, again, if I measured those 150 cardinals and the proportion of those cardinals that were diseased was 13%. Well, again, that would be a statistic. If that percentage, 13% diseased, came from the sample, it's known as a statistic. Now, if it came from the population of all cardinals, then it's a parameter. Now, it's actually pretty easy to memorize this because, think about this, parameters come from populations, PP. Statistics come from samples, SS. So most kids remember that, no problem. All right. Now, the idea, of course, is that if you could get the parameter through measuring the entire population, a census, that's a great scenario. But if you have to get a sample because your population is too big, well, then you're going to have to be using statistics because they come from a sample. No big deal. Now, remember, a couple key things here to remember. The way we collect data influences what we can and cannot say about that data or about that population. Meaning, if you collect data in a biased way, like if you collect cardinals and you only collect male cardinals, well, then all of a sudden, anything you learn from that sample of male cardinals can only be said to be true for male cardinals. It's the same thing with people. If you collect data from people that are high economic, socioeconomic, maybe they make $200,000 plus, then anything you learn from that sample can only be applied to people who make $200,000 plus, right? So your sample is only as good as where it came from. Let's make sure that you understand that. So when a sample is selected from a larger population, it must be selected randomly as well. That's the second big thing you have to remember. So populations are great. We love censuses because if you can do a census, you're going to get great data. But again, sometimes it is very hard and timely and costly to do. So if we do select a sample, you got to make sure that that sample is random. If it's not random, that's a problem. And one opposite of not being random would be what we call convenience, right? So a convenience sample is if you just go and say, you know what, I need 10 high school students, I'm just going to go get my 10 friends. That's just easy for me. Well, all of a sudden, that sample becomes honestly worthless. Anything you learn from that sample is not going to be good because it wasn't random. Samples need to be random. That's a huge fact. All right, now there are two ways that we could collect samples. So if you're going to say, listen, population's too big, I don't have time to go to the entire population, I can't do a census, I'm going to select a sample. There are kind of two ways to do this. One way is to sample without replacement. So when an item or person from a population can be selected only once, this is called sampling without replacement. So you're picking people to be a part of your sample. You picked Johnny, and you cannot pick Johnny again. So you're sampling without replacement. So imagine if you're picking out names out of a hat. So I got everybody in Twinsburg High School's name in a piece of paper, and I'm picking them out of a hat. And I pick out Johnny's name, and I do not put it back. That's sampling without replacement. Now, this is typically how sampling is done because you don't want a person picked twice. Like I want a sample of, let's say, 100 students, and I don't want 2 Johnnies, right? I mean, that's only 99 people technically, right? So you want 100 different people. So oftentimes we do sample without replacement. Now, you might say, well, why does this even matter? Like, this is stupid. Why are we talking about this? Well, technically it does matter because every time a person is picked and they are not replaced, then the probability of the next person being picked actually changes. Now, to try to make sure you understand this on a very small scale, think about if you have a bag of 10 M&Ms and you take one away and you do not replace it. You eat it, right? Well, now there's only 9 M&Ms left. So the probability of the remaining 9 M&Ms being picked is now 1/9. So it was 1/10 because there were 10 M&Ms. Every M&M had a 1 out of 10 chance of being picked. But now that you took one out, every M&M left has a 1/9 chance. And then if you take a second M&M out, now every M&M has a 1/8 chance. So every time you take something out and do not replace it, the probability is slowly changing. Now, does that matter? Well, sometimes it does, sometimes it doesn't. And, we'll talk more about that in the future, but that's a potential issue when you sample without replacement. Now, sampling with replacement is when an item or person from the population can be selected more than once. Obviously, this is where we replace them back in. So again, imagine that hat of names, and we pick out Johnny. Well, we write down Johnny's name. Johnny, you were picked. We're going to ask you a couple questions, Johnny, and then we're going to put Johnny back so he can be picked again. Now, what that does is it keeps it fair so that every time I reach into that hat, every single person has the same probability of being picked. It does not ever change because I'm putting those people back. So the only thing we typically say in that scenario is if Johnny's name gets picked again, well, put it back and pick another name because you already picked Johnny once. You don't want to pick him again. So both with replacement, without replacement, neither one is bad or good. It's understand that there's difference. Okay. Now, with that said, now that you understand replacement and non-replacement, right, which is really simple and overall not a big deal right now, there are 5 ways to select samples. Now, the 5th way is actually not a sample. The 5th way is a census, which we've already talked about. If your population is small enough that every single person could easily be reached and contacted for your observational study, for your survey, for your questionnaire, whatever it is you're doing, then a census is a great idea. You literally are going to represent the population if everybody is picked. That's awesome. But sometimes, as we've mentioned several times already, a sample is the best you could do. And if a sample is the best you could do, there are 4 ways to truly get random samples. Remember, if it's not random, it's automatically bad. That's convenient. We want a good sample, which is made up of randomness. So we have a simple random sample, which we typically abbreviate SRS. We have a stratified random sample, a cluster random sample, and a systematic random sample. Please do not misconstrue that any of these are better than others. I have them numbered, but that number is not an order of importance or anything. They're just 4 different ways to select a random sample. As we talk about each of them, we're going to talk about positives and negatives, pros and cons. But again, if you're looking for a random sample in any situation, these can all work to be good and random, but there's just good things and bad things to them all. All right. Let's talk about what a simple random sample is, SRS, simple random sample. This is a sample where every group of a given sample size, lowercase n, has an equal chance of being chosen. So once again, remember lowercase n is just the size of your sample. So let's just say that we're going to look for a sample of 40 students. A simple random sample simply says that any group of 40 has an equal chance of being picked. Notice that it doesn't say every person has an equal chance of being picked. No, because if you sample without replacement, that actually is not true. But I don't want to get into too many details right now. What I'm saying is that if you think of any group of 40, because it's truly random, that 40 could be picked. So if I'm thinking of all the students, I have 1,500 students in a school. Think of any group of 40. That group could be picked. Now, it might be unlikely, but it's possible. So let me explain. Could I get 40 guys? Well, I guess you could. I guess it's possible. If you're just picking names from a hat, it could be possible to get 40 guys. Now, I would bet it's probably unlikely for that to happen, but it's possible. Could I get 40 kids who all play a sport? Sure, that might happen. I would imagine it wouldn't happen. I would imagine some of those kids don't play a sport if it's truly random, but it's possible. That's the simplicity of a simple random sample, is that if you're getting 40 random people, any 40 people could be picked. Now, it's very, very simple. I can't make it any more confusing. I can't make it any easier. Any group of 40 could be picked. It's about every group. Now, I want you to understand, it might be very unlikely for me to get 40 girls who all have blonde hair and blue eyes. But that group needs to have a chance. And again, that would probably be crazy. What are the odds if 40 girls with blonde hair and blue eyes are picked? There'd be very, very low chance of that happening, but there's a chance. All right, now, how would you actually select your simple random sample? Well, we kind of talk about 3 ways of doing this. One way is to use what's called a random number generator. Now, there are literally programs out there that literally pick random numbers. So first, you would have to give everybody in your population a number. So every single student would get a number. And if you think about it, if there are 1,500 numbers or 1,500 kids in the school, then everybody would have to have a 4-digit number. So the very first person would be 0001. The next person would be 0002. Maybe you obtain a list from the central office and everybody gets a number. Now, why is it important that everybody gets 4 digits? Well, because if the last person has number 1,500, well, then it needs to be fair. So everybody has to have 4 digits, even if there's some zeros in the beginning. Doesn't matter. So then what you could do is you're going to use a computer program that literally picks random numbers. So a computer program, there's all kinds of them out there. Your calculator can actually do it. I'll show you in class. But you would just randomly pick numbers. And okay, congratulations, person 1241, you are picked. Congratulations, person 0149, you get picked, right? So you're literally going to pick 40 random numbers. Now, if any number's repeated, you got to make sure to ignore it, because remember, we don't want Johnny picked twice. We want 40 different people. And if there's a number that nobody has, you would just ignore it. You have to say that. I know it seems silly, but you got to make sure you say that in your description. All right. So if number 1792 gets picked, I would ignore it. Nobody has that number. I stopped at 1,500. Okay. Now, a second way to do a random number is pretty much exactly the same as the first way, but instead of using a computer program that generates random numbers, you use what's called a random number table. And I'm going to show you an example of this in one moment. But a random number table is literally a table of numbers. And instead of a computer picking numbers, it's just a table of random numbers. I'll show you an example of this. But again, you have to ignore repeats. If the same number comes up twice, you need to ignore it. If any number that nobody has gets picked, you ignore that as well. That has to be said. Now, the third way to do this is the kind of the classic, put everybody's name on a piece of paper, put it in a hat or a bowl, shake it up, and start pulling out names without replacement. That works. That would work, right? You would definitely get 40 random kids if you pick their names out of a hat. But I typically would recommend not using this method because, of some silly things, but there are things that you need to consider. What if somebody's piece of paper gets stuck in the brim of the hat? All of a sudden, they never had a chance to be picked. What if some people's names are longer, which means they were used a bigger piece of paper for their name, and a bigger piece of paper would be more likely to be picked? That's not fair. So I know that those seem silly situations, but that is why we tend to avoid using the paper out of a hat method. We like to completely make it random using a number generator or a number table. So the process is very simple. Everybody gets a number. Ignore repeats, ignore numbers nobody has, and start picking numbers until you have the 40 you want. So here's an example of a random number table. It's literally a random number table, right? Just random numbers. I pulled this off the internet. But again, if I'm using numbers 0001 through 1500, a lot of numbers need to be skipped. So I'm going to look at 4-digit numbers. So there is person 1. Well, nobody has that number. And you ignore gaps. These gaps are purely to try to organize the data. You ignore them. So there's the next person. Nobody has that number. Next person. Nobody has that number. Next person. All right, my first winner, 1160. Come on down. Congratulations. You are going to be a part of my study. Please fill out this survey. Next number, 5542, nobody has it. 2970, nobody has it. So listen, this sucks because a lot of people, it just takes a while, but this is a way to truly get an unbiased random sample of 40 people. It just might take a while because you got to ignore any number that nobody has, and you got to make sure to ignore repeats. And again, you're going to keep going until you get 40 different numbers. And it might take a while, but that is a great way to do it. Now, what are the pros here? It is truly random. It's truly random. Any sample of size n has a chance of being picked. It's very simple to do. Really not a ton of planning goes into it. Everybody gets a number. Don't allow repeats. Don't use numbers that nobody has and start picking. Now, the cons, it potentially could not represent the population. Remember, samples need to represent the population. And in a simple random sample, any sample's possible. So maybe you do get that weird sample of all boys. Well, then all of a sudden, it doesn't represent the population and you're in trouble. So that is a potential flaw, even if it's unlikely. Other potential problem is time consuming. I mean, just look at the example I started on the previous slide. Sometimes it takes a long time to do this, right? First off, just giving everybody a number might take a while. Like, you got to get a list of 1,500 names and just start numbering it. Like, that alone might take me a half an hour. Then I got to go through this painstaking process of picking numbers randomly from a table, and a lot of them are going to be skipped. And all of a sudden, that takes a while. So random sampling is time consuming, but necessary. All right. The second example of a way to select a sample is called a stratified random sample. Now, I mentioned earlier that all of these methods are all great. They're all good. They're all random. But I will say that this is my favorite. Just don't tell anybody I said that. This is a great way to get a sample. And if you learn about it, you'll know why. So a stratified random sample involves first dividing up the population into groups called strata. And we base it on shared attributes or characteristics. We call this homogeneous grouping. So you take your population of interest and you separate them into groups where everybody in each group has a shared attribute in common. So if I'm talking about students, maybe I do freshmen, sophomores, juniors, and seniors, something that they have in common, right? Then within each strata, a simple random sample is selected. So from the freshman strata, I randomly take out 10 freshmen. How do I do that? Well, then I got to go back to simple random. Every freshman gets a number. Repeats are ignored. Students with without those numbers get ignored, and I pick out 10. So that, again, is time consuming. Then I go to the sophomores. 10 sophomores randomly get picked. 10 juniors, 10 seniors. Now, finally, all the students, the 40 total people I picked, 10, 10, 10, 10, that becomes my sample. Now, why is this good? Because it represents the population. I'm going to get a nice mix of freshmen, sophomores, juniors, seniors, right? If I think that there is a difference in how freshmen are going to fill out my survey versus sophomores, juniors, and seniors, this is a fantastic, glorious idea because I'm going to get a great mix of students by doing it this way, representing the population. Let's talk a little bit more about stratifying. First off, the stratas, the groups, do not have to be equal in size. If there are more freshmen, then your freshman group is going to be bigger. What are you going to do? All individuals in each strata have one or more characteristic in common. Once again, when you put kids into a strata, when you put kids into a group, they have to have something in common that matters, like grade level. Or what, you know what? Maybe it's something as simple as males and females. Maybe you have two groups, males and females, 20 males get picked, 20 females get picked. If you think gender is an important characteristic and you don't, let's see, here's the issue, right? Remember, simple random, you could have ended up with all females. But by stratifying in this way, 20 males, 20 females, you're guaranteeing males and females. That's a great advantage to stratifying. Now, the other thing is this. How many people you take from each group does not have to be the same. Let me give you one more example of a way that you might want to stratify. Ethnicity. If you believe that the ethnicity of a person could affect the results of your survey, then you want to make sure that you get different ethnicities. So maybe you first create stratifies based on ethnicity. So white people, African Americans, Hispanics, Asians, Pacific Islander, Indian, right? You create these stratas based on their ethnicity. Now, if you know your school has a lot more African Americans, maybe you take out 20 African Americans. Maybe you take out 10 whites. If you know your school only has a very small amount of Asians, then maybe you only take out 2 Asians to be in your sample. It's allowed, as long as you take a couple from each. Maybe you take 1 Indian, 2 Pacific Islanders. The point is, 5 Hispanics, whatever, you have to take a couple from each. So the big idea here is you create groups based on something that they have in common, and then you take some from each group randomly. You don't have to take the same amount. You can do something that's intelligent, like taking more African Americans if there are more African Americans in your population, but you have to take some from each strata. That's the key. So again, you have a school of students. You break them up into groups. Whatever you want, you pick. You pick. What matters to you? Gender? Then just do males and females. Ethnicity? Then break them up by ethnicity. Grade level? Freshman, sophomore, junior, senior? Do it that way, right? I could sit here all day and list ways to break up a population of students. Maybe you break it up to, do you buy school lunch or do you not buy school lunch? 20 kids of each. But again, why would you break them up by lunch? Well, you would only do that if that's what mattered to your survey. So if your survey was all about school lunch, then yeah, I would probably want to break it up by school lunch and take 20 of each. That way you represent the population and how it relates to the questions that you're asking. Now, what are the pros here? Well, it really does create a diverse representative sample. If done correctly, you will get a very representative sample. That's just awesome. It will ensure the population is well represented. We love that. Now, the con is that it's not simple random. Now, you might say, well, why is that a con? Well, I'm just trying to say, right, remember simple random, 40 boys could have been picked. Right? Think about this. 40 African-American boys could have been picked. Very unlikely, but simple random is so simple that it could have happened. Whereas when we stratify, we guarantee that something like that does not happen. Now, this could be very, very time consuming because now you're going to each group, giving everybody a number. Nobody can have repeats. Numbers that nobody has have to be ignored. And then you're gonna go to that random number list and pick out 10 names. Then you're gonna go do it again, and then you're gonna go do it again. Right? It's very, very time consuming. But the pro is you're gonna get that great representative sample. All right, another way to do a random sample is called a cluster random sample. A cluster sample involves dividing up the population into smaller groups called clusters. Ideally, there is heterogeneity within each cluster. Now, you might be saying, okay, hold on, you lost me at heterogeneity. What the heck does that mean? In simple terms, you create clusters, groups, that are a nice mix of the population. This is the complete opposite of stratifying. When we stratified, we created groups that were very, very similar within. Now, with clusters, we create groups that are very, very different within. So here we're going to create a cluster that's made up of, males, females, African Americans, whites, Asians, Indian, right? We're going to make this group very, very diverse. So this group in of itself is very heterogeneous, which means very mixed up, very different. So this group is also going to be heterogeneous. Males, females, African Americans, rich, poor. It's going to be very mixed. Same with this group. Same with this group, right? So here's the idea. Each cluster is itself like a mini population. Think about that. Each cluster is itself a mini population because each cluster has a nice mix, which represents the population. Now, here's the key. Once you create your clusters, you only label the clusters. 1, 2, 3, 4. Then you pick one cluster, excuse me, to be your entire sample. So stratify, you take a couple of people from each group. No, not with cluster. Cluster, you pick one group at random. So maybe I'm going to use my random number table. Each cluster gets a number 1, 2, 3, 4. That would be pretty easy, right? I'm only have 4 numbers. Congratulations, number 3, you got picked. And then that entire cluster becomes my sample. Okay, what are we doing here? Well, what's the advantage here? We're still going to get a representative sample because remember, the clusters themselves are mini populations. Now, it's still random because any cluster could have been picked, but number 3 got picked. The advantage is it represents the population. The another advantage is it's a lot easier. It's a lot faster to do this because you don't label every person. You just label the clusters and pick one of the clusters to be your group. Let's talk a little bit more here. First off, once again, I want to emphasize the population is broken down into groups where the groups are in sense mini representations of the population. So any cluster that gets picked would represent the population well. Perhaps best used when the population is fairly undiverse, right? So to be honest, this method, clusters, I'm going to be honest, it's not used that often. But it's used if you have a very undiverse population where, listen, hey, you're at these groups, pick one of them to be your sample, okay? Now, I really want to make sure you know the difference between cluster and stratify because so many kids walk away not knowing the difference. Both of them involve creating groups. The biggest difference, there's 2 big differences, but the biggest difference is in a stratify, you go and do a simple random sample, taking a couple kids from each group. Then you have your sample. Cluster, you create your groups, and then you pick a group to be your entire sample. Do you see the difference? The second difference between them is in a stratify, your groups are built on something they have in common. So all the white people go into this group, all the African Americans go into this group, and so forth. Whereas in a cluster, each cluster is already a nice mixed up group. Males, females, different ages, different grade levels. So here's my thought, right? In a school, Twinsburg High School, how would this best work? Lunches. If you think about the 4 lunches, lunch A, B, C, and D, each lunch is kind of like a mini population. Each lunch has boys and girls. Each lunch has freshmen, sophomores, juniors, seniors. Each lunch has smart kids and dumb kids. Each lunch has different ages, different weights, different heights. Each lunch is like its own mini population. And then I label the lunches, and one lunch gets picked to be my entire sample. So, the pros, it's so much faster. You're not labeling the people, you're labeling the groups, making it so much faster to do the picking. You don't have to number all the people, and guess what? It's still representative. The cons, though, is that you do have to create the clusters. Now, if they're pre-created for you, like the lunches, well, that is awesome. But otherwise, it's hard to take a population, like let's say the population of Ohio, and say, all right, I'm going to make groups of males, females, rich people, poor people, socioeconomic people, people that make this much money, black people, Hispanic people, Latinos, and okay. Then all of a sudden, like at that point, you're doing way too much work just to create your clusters. It's going to take you forever. So typically we like to do a cluster when they're already grouped in a nice way for me, and then I select a group to become, randomly of course, to become my sample. All right, systematic is an easy one. I don't really have to spend too much time talking about this, but a systematic sample is where you simply have a list of all of your population, and you just simply say, hey, I'm going to select every kth person on that list to be in my sample. So let's just say I'm going to say, okay, listen, I got a list of all the kids at Twinsburg High School. I'm going to randomly start, point your finger, start somewhere, and then from that starting point, every 10th person on the list is in your sample. So you're just going to start counting. Every 10th person, they're in the sample. Every 10th person, they're in the sample. Every 10th person, it could be every 5th, every 4th, but a systematic sample is where you pick every kth person to be in your sample. That's pretty easy to do. Obviously, a census we've already talked about as well, where you select the entire population. But listen, censuses are very hard to do unless your population of interest is very, very, very small. All right, one more warning. Know and understand that there are disadvantages and advantages to every method. They're all great. They're all random, which is what we're looking for. but sometimes a certain situation might lead to a cluster being better than a stratified or a simple random being better than all of them. It all depends on the situation at hand. So you have to know how to read a problem and know what you're doing. So think about, we start off with formulating questions, right? That's step one. So if your question is, how does ethnicity affect depression? Well, gosh, dang it, right there, I think it would be super important for me to stratify based on ethnicity. I think I want a nice mix of different ethnicities in my sample, so stratifying is the only way that's going to guarantee that. So you got to really think about what do you want to know and how it impacts you. If there is nothing, if nothing else matters, like if gender doesn't matter, if age doesn't matter, then just do simple random sample, because at that point, who cares? So you got to really understand what it is you're looking for and how the different methods could impact your sample and how, what that might mean for what you want to do. And we'll talk a lot more about that in class as well. But again, you really got to think about what's the advantages and disadvantages, what am I measuring, what is my population, who do I care about, and what's best for me in this one situation. All right, that's it for this video. See you guys later.